Hello everyone, welcome to my class, Math Lesson with Miss Kenny. Today we are going to learn about sequences. We are going to learn about geometric sequences, quadratic sequences, and cubic sequences. Let's start with the opening problem here. I have two options, option A and option B. Choose between these options. If you choose option A, over the next 10 days, I will give you $10 on the first day, $20 on the second day, $30 on the third day, $40 on the fourth day, and so on. If you choose option B, over the next 10 days, I will give you $1 on the first day, $2 on the second day, $4 on the third day, $8 on the fourth day, and so on. Don't think too long about it. Which one you choose, option A or option B? Okay, let's take a look the difference between the two options here. If you choose option A, okay, let's take a look at this. At the end of the 10th day, you are going to gain $550. If you choose option B, at the end of the 10th day, you are going to gain $1,023. So take a look at this. Option A is an arithmetic sequence. Option B is a geometric sequence. Let's take a look at this. I've put the money in sequence. This is option A and this is option B. Option A is an arithmetic sequence. Option B is a geometric sequence. Let's take a look. Okay, you need to check between two consecutive terms, the difference between two consecutive terms. For the option A here, let's take a look. The difference between 10 and 20, 20 and 30, 30 and 40, 40 and 50. Okay, it turns out that the difference is common difference. It means the same for all pairs of consecutive terms here. Now, we can say that the term-to-term rule for the arithmetic sequence or the option A is add 10 here. Okay, what about option B or the geometric sequence? In geometric sequence, you are using multiplication. So because there is no common difference here, for example, between two consecutive terms, 1 and 2, you need to add 1. 2 and 4, you need to add 2. Okay, 4 to become 8, you need to add 4. 8 to become 16, you need to add 8. Okay, there is no common difference. So let's try multiplication. If I multiply the first term by 2, I'll get the second term. If I multiply the second term by 2, I'll get the third term, and so on. So 2 is the common ratio. Okay, so we can say that the term-to-term rule for this geometric sequence is multiply by 2. Okay, for the arithmetic sequence, you've learned about the nth term formula, which is the first term plus the multiple of d, this one. Okay, and then if we try to find the nth term, we need to replace the first term with 10 because the first term of this sequence is 10. Okay, after you get this, you need to simplify. It means you need to remove the brackets by multiplying 10 with the terms inside the brackets here. So you'll get 10n minus 10. And then you can cancel 10 and minus 10. Okay, so the nth term for the arithmetic sequence here is 10n. Okay, What about the geometric sequence? The nth term formula for this geometric sequence is the first term times the common ratio to the power of n minus 1. The same concept here, because the common ratio is multiplied begin at the second term here. That's why we need to reduce 1 here. Reduce the position number by 1. Okay. What about the nth term? To find the nth term of this geometric sequence, we need to replace the first term with 1 because the first term of this geometric sequence is 1. Okay, now we have the nth term for the geometric sequence. We also have the nth term for the arithmetic sequence. It's time to give you the question, what is the 15th term? It means the position number, the n, is 15. Okay, it means we need to replace n with 15. So we'll get the 15th term equals 10 times 15. So equals 150. Don't forget to underline your final answer twice. Okay, after that, what about the geometric sequence? What is the 15th term? Okay, we are learning about how to use the nth term here to find the 15th term. This is the position number, so this is n. All we need to do is to replace the n with 15. This 15th term equals 1 times 2 to the power of 15 minus 1. It means 2 to the power of 14. We need calculator to calculate this. You may use your calculator here to find the result here. So the 15th term of the geometric sequence, or the option B, is the 16,384. Don't forget to underline your final answer twice. This is how we use the nth term formula to find the 15th term of the arithmetic sequence and geometric sequence. Okay, next. An arithmetic sequence is a list of numbers in which the difference between two consecutive terms is constant. Okay. A geometric sequence is a sequence of numbers in which the ratio between consecutive terms is constant. So the difference here is that arithmetic sequence use difference and geometric sequence use ratio. This is the nth term formula for the arithmetic sequence, and this is the nth term formula for the geometric sequence. There is another name for geometric sequence that we are going to use in this lesson, okay, which is exponential sequence. So geometric sequence and exponential sequence are the same. Do not be confused. Next, we are going to learn about applications of exponential sequences. So let's take a look at this example. Tony deposits $500 in a bank account. The bank offers 6% interest per year. Assuming Tony does not take any money out of the account, calculate the amount of money in the account after 5 years. The minimum number of years the money must be left in the account for the amount to be greater than $600. First, let's make a sequence here. Start from 500, and then at the end of the first year, Tony will gain $530 from 500 times 1.06 here, like this one. Okay, next, at the end of the second year, Tony will gain $561.80. Next, at the end of the third year, Tony will gain $595.51. In writing money, we are using the 2 decimal places. Okay, you need to round off to 2 decimal places here. Okay. At the end of the 4th year, Tony will gain $631.24. At the end of the 5th year, Tony will gain $669.11. Okay, if we are using the nth term formula, okay, we can write down 500 times 1.06 to the power of 5. Remember, there are 6 terms. 1, 2, 3, 4, 5, 6. You need to reduce by 1. Okay. So don't be confused. Do not reduce the number of years by 1. Okay, because the number of years is 5. If you reduce by 1, you'll get 4, and that's not correct. Okay. Just use the years immediately without reduce by 1. So 500 times 1.06 to the power of 5 equals $669.11. Underline your final answer twice. Okay. This is the difference between using the nth term formula in geometric sequence and in real life example. Okay, let's answer the question B. The minimum number of years the money must be left in the account for the amount to be greater than $600. See, the money must be left at least 4 years here. Okay, you cannot say 3.5 years because the bank offers the interest per year, not per half year. Okay, this is the example of the application of exponential sequence in real life. Next, we are going to learn about special number sequences.